Well, good morning, ladies and gentlemen. I hope everything's going, excuse me, going well for you. Uh, I promise that wasn't a COVID cough. Anyway, what is today? It's September 8th, 2020. We're going to go ahead and work through this Cambridge IGCSE. This happens to be a paper 2. And yeah, right here, paper 2 extended. So extended means you're college bound. So let's go and work through this. First thing you always want to do is you want to read all the instructions, right? So if you were taking this officially, you make sure you use a pen or black or blue, and you only use a pencil if you are filling out a diagram or a chart or something like that, right? And you can put your name on it, all that kind of stuff. Here, we're trying to focus this wonderful thing right here. There we go. All right, so let's go ahead and crack this open. You got this reference chart. This is fantastic to use. Sometimes there's things in here that they give you some information that you might not have seen in class, and you're going to have to use it. So if you're ever stuck, refer to that. Okay. Also, it'll often tell you how you round and all of those kinds of things. This is not a calculator test, so there is no rounding going on. Anyway, let's get to it. So first up, it says to simplify the square root of 9/16 plus 2 to the power of negative 1. So that's 3/4 plus 1/2. Right? 3/4 plus 1/2. So yeah, 1/2 is the same as 2/4, right? So that is 5/4 or 1 1/4. Make sure you show your work, and you can put it, you can put either answer there. But show them both, put your answer right here in the block where it goes, boom, done. All right, now find the value of y when x is 0.1. So we're just going to plug in 0.1. So we got 0.1 over 2 plus 0.1 squared, I do believe is 0.01. 0.01 over 1, right? So we have to multiply that by 2 over 2. So we've got, here's what we've got. We've got 0.1 plus 0.02, so that is 0.12 over 2, and that can be reduced to 0.06. So 0.06. Boom, done. All right, solve the equation. This is just inverse operations. Multiply both sides by 2. So go ahead and make sure you show your work. Add 8 to both sides, and equals 30. Good to go. All right, so now let's go ahead and move on to this next one here. Oh man, this is where it gets a little tricky. So the number one issue that students have with these IGCSE tests is they don't read. So it says in the space provided, write each number in this calculation correct to a single significant figure. So this is 5, this is 2, and this is 20. 5, 2, and 20, you see? And of course, if you simplify that, so use your answer in part A to estimate the value of this. So that's going to be 10 over 20, which is 1/2 or 0.5. Yeah? All right. Moving on to the next one. Here we go. So let's see here. Let's see, make sure we can see it all there. So this says 3 times the square root of 2 squared. So that's going to be 3 squared times the square root of 2 squared, which is just 2. So this is 9 times 2, which is 18. All right, now simplify this. So 4 times 6 is 24. The square root of 4 is 2, so 2 root 6. 9 times 6, oh look at that. It's almost like they wrote it so you could add them together. Those are like terms, boom, done. All right, now, ratios. All right, so here's what we got. We got an exchange rate problem, right? So Carlos changed 80 euros into dollars, and the exchange rate was 1 euro was worth $1.50. He exchanged, then he spent $88, and he took whatever was left over and exchanged it back, but the exchange rate was now 1 euro for every $1.60, so you're supposed to work out how much money he received, right? So euros to dollars, so we have $1.50 to 1, and he exchanged, we don't know how many dollars it was, but he exchanged 80. So this is $1.50, so that's going to be 1.5 times, so that's going to be 120, right? So 1.5 times 80. So 1.5 times 80. So 0, 0, oh man, 8, 12. Oh, look at that. And boom, 120. So that's $120 he had, right? Now you could have figured that out without showing your work, but see, this is where 3 problems, so show your work. That way if you make a silly mistake there, you might still get, you could even, sometimes you can get full credit. Sometimes you get just 2 out of 3, but if you don't show any work, when you have mistakes, you're not going to get any points at all, right? All right, now, that's how much he had. So he spent $88, right? And so that's $32 left, I think. So let me let me make sure. 32, so no calculator test. Oh, look at that, 120. All right, so good. So he had $32 left. Now, he's going to exchange that $32 back into euros, but now it's 160 for one, and he has $32, and he doesn't know how many euros. So this is euros over dollars, right? So 32 divided by 1.6, I do believe that's going to be 20, right? So, you know, we could do 320 over 16. Yeah, 20. So 20. Boom, done. All right, next up, Buttercup says solve for x. We got y equals x minus 4 squared plus 6. So we're solving for x. This is just inverse operations. We have to get rid of this first, then we're going to take the square root, and then we're going to add. So we're going to get y minus 6 equals x minus 4 squared. Take the square root of both sides. We've got the square root of y minus 6 equals x minus 4. So we've got, we're going to add 4 to both sides. So I'm going to write it like that. 4 plus the square root of y minus 6. Now, man, check this out. It's a square root. This could be a plus or a minus. We don't really know because there's 2 answers to that, right? So I'm not really sure if we would lose points for this if we didn't put the plus or minus, but yeah. Now, I do believe also you could have written it like this as well. The problem is sometimes that you write that 4 as it looks like it's inside the square root symbol, like it's part of the radicand, and then you end up adding together inappropriately. So let's not do that. All right, next up, Buttercup. Write as a single fraction in simplest form. Now look, people have a terrible time with this. What they want to do is they want to add 1, and that's no good. We need a common denominator, which is going to be, these are relatively prime. They don't have a common factor, so that's what our denominator is going to be. Do you see? So we have to multiply this one by x over x. We get minus 2x. We have to multiply this by x plus 1, x plus 1. So that's going to be 2x plus 2. 2x plus 2. We can simplify that, right? See, 2x minus 2x, well, that's 0. So 2x times x plus 1. So that's our answer 2. Make sure you write your answer here. Be nice to the grader. Don't make them search and hunt. Don't want to make them mad, right? All right, now, it says here that a bus company in Dubai has the following operating times. This is in 24-hour time, not 12-hour time. So, all right, so it says, calculate the total number of hours that the bus company operates in 1 week. Well, this is 6 a.m. to midnight, right? So that's 18 hours. So 6 to 12, 6 to noon is 6 hours, right? And then, you know, noon to midnight is 12, so that's going to be 18 hours. And that's going to be 1, 2, 3, 4, 5, 6 days a week. And then this one is 11 hours. So 8, 4, 6, 108 plus 11, that's 119 hours. Okay, 119 hours. Now, it says, write the starting time on Friday, which is right here, in the 12-hour clock. So 1,300 hours is 1 p.m. Boom, and done, and we are just riding fancy today. Okay, next up, Buttercup. It says to factor that hotness. That's factor by grouping. Look, we have 1, 2, 3, 4 terms. So I don't think we need to rearrange this yet. So look, we can take out an a, x plus y, and we can take out a b, x plus y, and then look at that. This and this are the same. This right here and that right there are the same. So we have a plus b, x plus y. And if you were to distribute this, you would get ax plus ay, and then plus bx plus by, just like that. Boom, done. All right. In fact, if you were to write this out and not use a shortcut like FOIL, if you were to write this out, this would be your very first step. And then when you distribute, you get that. So, all right. Now, this one says 3 parentheses x minus 1 squared plus parentheses x minus 1. They were nice to put this in parentheses for us because if you look, those are like terms. We can factor out an x minus 1. And when we factor x minus 1 out from x minus 1 squared, we still have x minus 1. Okay, let's take a look at this. If I distribute x minus 1 to this, I get 3 x minus 1 times x minus 1, which is x minus 1 squared, plus x minus 1. So we're good there. Let's go ahead and distribute right here. This is going to be 3x minus 3 plus 1, so that's going to be x minus 1, and then 3x minus 2, because negative 3 plus 1, negative 2. So x minus 1, 3x minus 2. Boom, done. Probability. So bag A contains 2 white and 4 black. Bag B, 1 white, 5 black. So there's 6 in each, right? So 6 in each, and it says Alex chooses a bag and then takes a bead out at random. But apparently there's something wrong with this one because it's only got a 1/4 probability of being chosen. And so we got to figure out what's the probability that he chooses a white bead, right? Well, for bag A, there's only a 1/4 probability that he chooses it. If he does, then there's 2 out of 6, right? There's another way. This is for bag A. For bag B, there's a 3/4 probability that he chooses that, but there's a 1/6 probability. So let's go ahead and do some reducing right here. That's 1/3, so that's 1/12. Plus, this is why you often don't reduce. So let's not reduce, okay? So 2 out of 24 plus 3 out of 24. I'm not very good at math, but I think that's going to be a 5 out of a 24. Man, look at that fanciness right there. So this is an example of why reducing with probability sometimes is a little counterproductive. It can give you some extra work. Okay, next up, Buttercup, number 12. We're moving right along. This is supposed to be a, let's see, there's 70 total points. I think this is a 90-minute test. Yeah, 90-minute test, hour and a half. We're killing it. Okay, number 12 says P equals 4 times 10 to the power of 5 and Q equals 5 times 10 to the power of 4. And give your answer in scientific notation. Okay, scientific form means scientific notation. So P times Q, so that would be 4 times 10 to the 5th times 5 times 10 to the 4th. So that's going to be 20 times 10 to the 9th. Okay, now this is not scientific notation. So we need to do 2.0 times 10 to the power of 10. Okay, these two numbers are exactly equal. This says it's 20 followed by 9 zeros. This says a 2 followed by 10 zeros. Same thing. All right, now Q divided by P. Q divided by P. It's so easy to mix those up, so you got to be really careful. And then they give you these numbers that to me they're so easy to mess up. So look, that's 1.25, right? 5 divided by 4 is 1 1/4, right? And then times 10 to the power of -1. Boom, done. That's it. So 1.25 times 10 to the power of -1. All right. Let's see. Oh boy. So circle problems. A couple things. I always mess up circle problems because I often fail to recognize when I have a radius. Whenever I have a radius, I end up with an isosceles triangle like that. Okay, now let's see. We got a 23-degree angle that's marked. We have a 58-degree angle that's marked. This is an inscribed angle that lies on this chord. That's a central angle, so that's going to be twice as big. That's going to be 116 right here. I'm going to write 116 right there. Okay, now calculate angle OCA. That's this one. Ooh, so if it's 116, let me make sure. Because let's see. Yeah, 116. There we go. So that is 116. So 64 divided by 2 is 32. So I'm going to say that that's a 32-degree angle. Make sure you write your degrees. Sometimes they mark you wrong if you don't have your units, and a degree is a unit. Okay, angle DCA. DCA, so that's this angle right here. So that's 23. You see this right here? A, B, C, D, that's a cyclic quadrilateral. So that means these two angles right here are supplementary. They add up to 180. So 180 minus 58, that's going to be 122, right? 122. And then that other angle's 23, so that's going to be 145 degrees. And then that's within a triangle, so 35 degrees. So this one's 35 degrees, because this is 122 and this is 23. All right, trucking right along. Oh man, we got some middle school math here. Man, we had some less than middle school math a minute ago. So here's what we've got. We've got that point A and that point B. The coordinates are listed and they're on line AB, of course. This is a perpendicular bisector. Oh, that means it makes a right angle, and that means those two are the same, and that means this is in the middle. Man. So the perpendicular bisector of AB has a slope of 2/3. So this has a slope of 2/3. That means that this one has a negative slope of 3/2. All right? Facts are important, right? All right, properties. So find the equation of the perpendicular bisector of AB. So that means we're finding this equation right here. Well, you know how you've got y equals mx plus b, that's the equation of a line. We know this is 2/3, but we don't know x, we don't know b, and we don't know y, right? But this is a coordinate right here, x comma y, and we can figure that out because it's the bisector. That means this is the midpoint. So if I have a 5 and a 13, divide that by 2, and then I have a 10 plus negative 2 divided by 2, so that's 9, because it's 18, right? Divided by 2, and that is 8, that's 4. So that coordinate right there is 9 comma 4. Okay, so since x is 9 and y is 4, let's go ahead and plug these in. That's 3, that's 6, right? So we're going to subtract 6 from both sides. Negative 2 equals b. So we have y equals 2/3 x minus 2. Boom, done. That is a 4-point question. That seems pretty generous for something that's middle school level math. Man, 4 points. 4-point question. Interesting. Okay, now solve the inequality for, ooh, man, reading is important. Positive integer values of x. So 0 is not positive, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, right? Positive integers. All right. Well, this one's a little tricky because we have an x on each side, and we also have a rational expression over here. So what I would do is I would multiply both sides by 5 first, like that. Good. Now get the x's together on one side. So I'm going to subtract 5, and I'm going to add x. I'm going to add x. I'm going to subtract 5. So 16 equals 6x. No, not equals. Is greater than. 16 is greater than 6x. So divide both sides by 6. Divide both sides by 6. That's reducible. That's 8/3. Yeah? Hold on. I have a feeling that we're doing something silly right here. So 21, that's 16. Yeah. Yep, 6x. So 8/3. Well, I still feel like something's wrong. So we got 5x plus 5. I'm going to do this problem again in just a second, okay? And that's greater than x. I'm not sure. Something's not right. It's just kind of sticking with me. Divided by 2. So anyway, that would be 1 and 2. Because 8/3 is a little less than 3. All right. So I'm going to try this one more time. I'm going to start all the way over. 21 plus x over 5. Just have a sneaking suspicion that I did something wrong. So I'm going to multiply both sides by 5, right? Multiply both sides by 5 over 1. And you get 21 plus x is greater than 5x plus 5. So subtract 5 from both sides. Right? Subtract 5. That gives you 16 is greater than 6x. So divide by 6, divide by 6. Now that's reducible. 8/3. Interesting. I still think I'm doing something silly right there. 8 over 3. I'm going to come back to this one again at the end. All right. So anyway, moving on to greater things. So I didn't write my answer here. I'm going to try that one again. All right. I'm going to try it with pencil next time. Sometimes when you feel like, sometimes when something's not right, you keep making the same mistake, you got to come back to it. Okay. So this says find the value of p. So p to the 4th. So here's what we got. We got 2 to the power of 24 that's raised to the 1/2 power. Those can be multiplied. Half of 24 is 12 equals p to the 4th. Oh man, so these aren't equal, obviously, right? But we need this to be a 4. So 2 to the power of 3 raised to the power of 4 is still 2 to the power of 12. Would you agree with that? And so 2 to the power of 3 is 8. Done and done. Okay, now to simplify this, that q squared plus q squared is 2q squared. And those are same base, right? So you're gonna add those exponents. 1/2 plus 1/2 is, or sorry, 1/4 plus 1/4 is 1/2. And so you're gonna subtract those. So 2 minus 1/2 is 2 minus 1/2 is 1 and 1/2, which is 3 over 2. So I've got 2q to the power of 3 over 2. 2q to the power of 3 over 2. This one's still bugging me. I got to come back to that. So 2q to the power of 3 over 2. All right. Moving on. All right. Let's see here. All right. That reminds me of one thing. You see, they give you an hour and a half. It won't take you an hour and a half. You do the whole thing, and then you just circle those problems that you're not sure about, you want to come back to, and then you do that. All right. So let's see here. It says that a travel brochure has 72 holidays in 4 different countries. And it says the pie chart shows this information, right? So it says that in Thailand there are 24 holidays, show that the angle is going to be 120 degrees. Okay, so first of all, 72 holidays, so all of these holidays have to add up to 72. So the way we figure out how many each country gets is we divide 360 by 72. So that's divisible by 9. We got 40 over 8. Oh man. Paper 2 problems, the arithmetic will always work out easy like that. Doesn't mean you can't make a mistake. We always make mistakes. That's how most of us got here, right? And see what I did there? Okay, so what this number is it's 5 degrees per holiday. That's what that is. Okay, so like that's 5 degrees per holiday. So 120, if there's 24 holidays, 24 times, well, we'll do it this way, 24 times 5, 0, 2, 120, you see? So 24 holidays times 5 degrees equals 120 degrees. It says show that, so I think that's what it wants us to do right there, right? It wants us to find how many degrees per holiday, and then multiply that by 24, that's how many Thailand has. All right. Next up, it says the sector angle for Malaysia is 150 degrees, which we see. The sector angle for Singapore is twice of Hong Kong. So if that's x, this is 2x, right? Calculate the number of holidays in Hong Kong. All right. Well, we know they all add up to 360, right? We have those two add up to 270. So if I subtract, I get 90. So Singapore, which is 2x, plus Hong Kong, which is 1x, is going to equal 90 degrees. Okay, so we have this and that, they have to equal 90. So Singapore plus Hong Kong, right? And we can solve this for x. So we get 3x equals 90. So x equals 30 degrees. Okay, now that's how many degrees it is. It's not how many holidays. But we already know that it's 5 degrees per holiday. So that's 6 days. 6 holidays. 6 holidays. Boom, done. 6 holidays. All right, moving on to the next one. Number 18, number 18. Oh man. Got scale factor for volume here. It says a solid cone has a radius of 4, a height of 12. They are mathematically similar. Ooh, that means that the corresponding parts are proportional, all that kind of stuff. and the top is removed, the volume of the cone that is removed is 1/8 of the volume of the original cone. So check this out. When you're talking about scale factor for volume, it's cubed, right? Whatever it is. So if we have 1/8, that is something cubed, the scale factor cubed. So I have to take the cube root of that to find the linear scale factor. So that is our scale factor that's linear, is 1/2. Okay, 1/4 would do for area. Okay, explain why the cone that is removed has a radius of 2 and a height of 6. Well, if that's the volume scale factor, and if I take the cube root of that, I get 1/2. And this will be the scale factor for length. Okay? Alright, so now, if the original height was, no, the radius is 4 times 1/2 is going to give you 2, and the height, which was 12 times 1/2, gives you 6. So I think that's a sufficient explanation. All right, now the volume of the remaining solid. Okay, so now it says that the volume of this top cone is removed. So this remaining solid right here, the volume of that remaining solid is K times pi centimeters. K times pi centimeters, and we got to figure out that volume. So the way I would do it is I would take the volume of the entire cone, right? Let's say that's the big cone, and I would subtract the volume of the small cone. Okay? So the volume of the big cone is 1/3 pi r squared times height. Right? Area of the base times the height times 1/3. That's the formula. Oops. 1/3 pi r squared h. And in case you forgot that formula, formula of a cone with radius r and height h. 1/3 pi r squared h. Boom, done. All right. 1/3 pi r squared h. Then we're going to subtract this one. 1/3 pi 2 squared times 6. Okay, and that's going to give us what's left. Because when we take the top off of the big cone, all that's left is our truncated cone. There's a name for that shape. I forgot what it's called, but yeah, anyway. That's what's remaining, right? So, 16 times 4 is 64 pi minus 2, 4, 8, 8 pi. So that is 58 pi. 58 pi. And so then there's no pi in that answer, of course, right? 56 pi. I knew something was wrong. 56 pi. 56. There's no pi in the answer, so it's just 56. Okay, last one. Last one. All right. Man, it's easy to make mistakes on these. That's why we go back. I'm glad I caught that. There was something in my mind going, wait a minute. Okay, here's what we got. We've got this diagram right here. It's a rectangle ABCE, and we have a sector, which is ADB. It's got an angle of 30, and this has an angle of 60, and we're supposed to figure out the perimeter of this shaded region. All right, well, here's what I know about a 30, 60, righty, 30, 60, 90 right triangle, right? So 60, 30. So this is 1, that's 1/2. This is the square root of 3 over 2, 1/2 times the square root of 3, okay? So that's really, really important, because if this is 60 and this is a rectangle, then this is 30. That makes this the short side. The short side is half of this hypotenuse. You see this triangle right here? This triangle right here? This is going to be 4, and this is going to be 4 root 3. Ah, okay, so this is 4. So we know that this entire distance is 8, right? So this part right here is going to be 8 minus 4 root 3. Do you see? Because from here to here is 8 because it's a rectangle. This part, that's from E to D, is 4 root 3. So the whole thing is 8. If I subtract this away, that's what's left, right? So DC, from D to C, is that. And C to B is 4. Now I got to figure this part out right here. This arc right here is going to be 30 degrees out of 360, right? And the perimeter is 2 pi r is 8. So let's go ahead and simplify this. This is 16, of course, and this is 1/12, right? 30 out of, right? So it's 16 over 12 pi. That's going to reduce to 4/3 pi. All right. So here's what we've got. We've got let's go ahead and figure this out right here, right? So we've got, to do the perimeter, we have DC, right, plus CB plus the arc DB, right? The arc DB. So DC, let's see if I can get all this on the camera right here. So D to C is 8 minus 4 root 3. That's DC. Plus BC, which is just 4. Okay? From here to here. And then the last part, we just found out the arc, DC, was 4/3 pi. So all we got to do is just combine all this up and clean it up a little bit. 8 plus 4 is 12 minus 4 root 3 plus 4/3 pi. Now, it says A, B, and C. So A is 12, right? Plus 4 root 3 plus 4/3 pi. Boom, done. All right. So I feel pretty good about this test, except for, see, I did mess that one up. 64 minus 8 is not 58, it's 56, right? And this one I'm not sure about. So let's see here. This one I'm not sure about. So solve the inequality for the positive integers of x. So 21 plus x over 5 is greater than x plus 1. So I'm going to go ahead and try this again. 21 plus x, 5x plus 5, right? Because I multiply that by 5, multiply this by 5, those reduce, so that's 5x plus 5. Okay, that's good. Oh, I see it. I see what I did. Oh my gosh. Man, every time it's always something like that. I have to subtract. So that is 16 is greater than 4x. So 4 is greater than x. So that would be 1, 2, and 3. Those are the positive integer values. Oh man, I hate when I do stupid stuff like that. And I did it. Oh my gosh. I tried to make it all fit right there. Such a silly mistake. But man, 4-point problem. Dang. Easy one too. So anyway, I hope this has been helpful. I know it's been a little long. That took 33 minutes. So, I've been doing Cambridge math for a long time. And it might take a student twice as long. But if it took twice as long, you're still going to have, almost a half an hour. You're still going to have over 20 minutes left to go back and review anything you might have done wrong and any mistakes you might have made. So this is a very approachable test. That's 70 points. That's 70 points out of the total of 200 that you need, that you take on the combination of paper 2 and of paper 4. And it's often the case that you don't really need a very high score to just get a C, which means you're college ready. So anyway, hope this has been helpful. You guys have a wonderful day, and I'll talk to you later.